Now we are starting a new compound, the nitromethane. Nitromethane is an organic compound with the chemical formula CH3NO2. It is the simplest organic nitro compound. It is a slightly viscous, highly polar liquid, commonly used as a solvent in a variety of industrial applications, such as in extractions, as reaction medium, and as a cleaning solvent. As an intermediate in organic synthesis, it is used widely in the manufacturing of pharmaceuticals, pesticides, explosives, fibers, and coatings. It is also used as a racing fuel in top fuel drag racing, and as an important component in the fuel for miniature internal combustion engines that are used in radio controlled models. Now, the method of preparation. Nitromethane is produced industrially by treating propane with nitric acid at around 350 to 450 degrees centigrade temperature. This exothermic reaction produces the four industrially significant nitroalkanes, nitromethane, nitroethane, and one nitropropane and two nitropropane compounds. The reaction involves free radicals, including the alkoxyl radicals of the type CH3CH2CHO, which arises via the homolysis of the corresponding nitrite ester. These alkoxy radicals are susceptible to carbon single bond carbon fragmentation reactions, which explains the formation of a mixture of products. Although inexpensively available, nitromethane can be prepared in other methods that are of instructional values. The reaction of sodium chloroacetate with sodium nitrite in aqueous solution produces this compound. The reaction is CH2Cl-COONA plus NaNO2 plus water. It gives CH3NO2 plus NaCl plus NaHCO3. Derivatives. In organic synthesis, nitromethane is employed as a one carbon building block. Its acidity allows it to undergo deprotonation, enabling condensation reactions analogous to those of carbonyl compounds. Therefore, under base catalysis, nitromethane adds to aldehyde in 1,2 addition in the nitroaldol reaction. Some important derivatives include the pesticides, chlorpicrin, Cl3CnO2, and tris hydroxymethyl nitromethane, HOCH2 whole thrice CnO2. Reduction of the latter gives tris hydroxymethyl aminomethane, HOCH2 whole thrice CnH2, better known as tris, a widely used buffer. In more specialized organic synthesis, nitromethane serves as a Michael donor, adding to alpha beta unsaturated carbonyl compounds via a 1,4 addition in the Michael's reaction. As an engine fuel, nitromethane is used as a fuel in motor racing, particularly drag racing, as well as for rockets and radio controlled models such as cars, planes, and helicopters, and is commonly referred to in this context as nitro. The oxygen content of nitromethane enables it to burn with much less atmospheric oxygen. The reaction is CH3NO2 plus 3O2, it gives 4 CH3NO2 plus 3O2, it gives the 4 CO2 plus 6 H2O plus 2 and 2. 14.7 pound, that is 6.7 kg of air is required to burn 1 pound, that is 0.45 kg of gasoline, but only 1.7 pound, that is 0.77 kg of air for 1 pound of nitromethane. Since an engine cylinder can only contain a limited amount of air on each stroke, 8.7 times more nitromethane than the gasoline can be burned in one stroke. Nitromethane, since an engine's cylinder can only contain a limited amount of air on each stroke, 8.7 times more nitromethane than gasoline can be burned in one stroke. Nitromethane, however, has a lower energy density. Gasoline provides about 42 to 44 millijoule per kg, whereas nitromethane provides only 11.3 millijoule per kg. This analysis indicates that nitromethane generates about 2.3 times the power of gasoline when combined with a given amount of oxygen.